You walk into a coffee shop, pull out your phone, and tap the Wi-Fi network. The little checkmark instantly pops up, and you're online. It feels instantaneous, but your phone can't actually communicate on that local network until it has been assigned a specific, unique digital identity. Looking at this technical breakdown, a host device requires 3 absolute minimum pieces of information: an IP address to identify the device, a subnet mask to define the specific network, and a default gateway to grant access to the wider internet. Without those 3 exact configurations perfectly aligned, your phone is effectively invisible and completely cut off from the web. Imagine a scenario where, instead of an automatic connection, the barista has to take your phone and manually type in a unique string of numbers just so you can check your email. Static addressing, listed here, is meant for permanent fixtures like printers, offering network control. But configuring static addresses for mobile devices is a nightmare. It is incredibly time-consuming, and a single typo could assign the same address to 2 hosts, breaking their connections. The sheer friction of manual entry makes large-scale mobile networking impossible. The system requires an automated solution. The answer to that bottleneck is dynamic IPv4, which relies on a centralized network traffic cop known as the DHCP server. According to these specs, a DHCP server runs continuously in the background, automatically handing out available IPv4 addresses to any client that asks. In small environments, like a cafe or your living room, the wireless router itself accesses this server. This removes human data entry from the equation entirely, replacing that slow barista with a high-speed digital handshake. That digital handshake is a precise 4-step conversation that happens in a fraction of a millisecond the moment you hit connect. Network engineers call it the DORA sequence. Step 1. Discover. Your phone broadcasts to the local network, requesting an IP and offering its MAC address. Lacking an identity, it uses destination IP 255.255.255.255 and frame MAC address of 48 ones. Step 2. Offer. The DHCP server replies, proposing an IP address. At this split-second mark, the machines establish mutual recognition. The IP address has been offered, but it hasn't actually been assigned to your device yet. Step 3 is request. Your phone replies to the server, officially claiming the proposed IP address. Finally, step 4 is acknowledgement. The server confirms the transaction, strictly recording the leased IP address against your phone's specific MAC address in its database. In a small cafe, this happens between your phone and the router on the ceiling. But on a massive corporate campus, the physical server handing out these addresses might be located in a completely different building. As this slide explains, networks bridge that gap using DHCP relays. Local routers catch your phone's initial broadcast messages and forward them straight to the distant server. Whether the server is 3 feet or 3 miles away, the DORA architecture functions exactly the same, abstracting the routing complexity away from the user. There is, however, a critical detail about the address your phone just received. It is not yours forever. As detailed in these dynamic IPv4 parameters, the address assignment is not permanent. It is merely leased to your device for a set period of time. When you grab your coffee and walk out of Wi-Fi range, the network recognizes we disconnect. It reclaims that specific IP address and drops it right back into the general availability pool for the next customer who walks through the door. This continuous, invisible cycle of leasing and reclaiming ensures networks never run out of finite IP addresses. It's the background mechanism that makes our mobile, constantly connected world possible.